Okay, in Learning Assessment 8.8, we're asked to find the current I of t in the circuit, and I of t is the current flowing out of the source. We're going to use the problem-solving strategy entitled Basic AC Analysis. And step 1 in that strategy says express V of t as a phasor and determine the impedance of each passive element. Well, to start, if you'll note, we're given a sine wave, and our phasor transformation was defined in terms of a cosine. So we need to take our source voltage and convert it to a cosine wave. So we have 120 sine 377t plus 60 degrees. And now we convert it to a cosine using the trig identities given in the text. We'll subtract 90 degrees, and that'll give us V of t is 120 cosine 377t minus 30 degrees. Okay, so now that we have it expressed as a cosine, we can convert it to a phasor. V with a bar, and in the textbook, phasors are indicated by bold. Here we're going to use a bar to indicate a phasor, and if we can convert it to a phasor, V bar is 120 at an angle of minus 30 degrees. So there's our phasor for the voltage. Now we need to convert the impedances, or convert our elements to impedances. For instance, the impedance of the resistor, Z sub R, we know that's just R, so that's 20 ohms. For an inductor, Z sub L is J omega L, so we have J. Now the omega is given here. Okay, omega is equal to 377, so we have J 377 times 40 millihenries, and that's J 15.08 ohms. And then for our capacitor, Z sub C is 1 over J omega C, so we have 1 over J 377 times 50 microfarads, and that's minus J 53.05 ohms. So now we've completed step 1. Now for step 2, we're going to combine impedances and solve for the phasor current I. So let's draw the frequency domain circuit for this problem. So here's our circuit. Circuit looks the same. Okay. For our impedances, we'll have 20 ohms for the resistor, J 15.08 for the inductor, minus J 53.05 for the capacitor. Our voltage source, now we have a phasor 120 at an angle of minus 30, and here's our phasor current I. And now we want to combine impedances and then be able to calculate the phasor current I. If we note, for instance, these two elements are in series and they're in parallel with this capacitor. So let's combine those in parallel. So for instance, Z equivalent, we'll call it. We'll take the product over the sum. Okay, so there's a product, and in the denominator we'll have the sum. And this turns out to be 30.96 at an angle of 9.24 degrees. So now our phasor current I is this voltage divided by this equivalent impedance, so we have 120 at an angle of minus 30 divided by 30.96 at an angle of 9.24, and that's 3.88 at an angle of minus 39.24 degrees. And now we can go through and complete step 3, which says convert the phasor current I to I of t. So then I of t is 3.88 cosine 377t minus 39.24 degrees.